All right, let's dive in. Today, we're digging into a really fascinating academic paper that, get this, uncovered a subtle but absolutely massive flaw in Git. You know, one of the most fundamental tools we all use in software development.
So let me ask you something. What if a tool you trust, I mean completely trust, something you use every single day, what if it had a hidden flaw? Not one that crashes your machine, but one that's, silently corrupting the very data you rely on. Well, that's exactly the mystery we're going to unravel today. And believe it or not, it's hiding right inside Git.
The command at the very heart of this whole thing, it's one every single developer knows, git diff. But here's the secret, the part most of us never think about. Git diff isn't just one thing. Nope, it's more like a front for a bunch of different algorithms working in the background. And the choice of which algorithm it uses, well, that's this hidden variable that can totally change what you see on your screen.
So let's pull back the curtain on this hidden variable, shall we? I mean, most of us, we just run the command and we trust the output, right? But it's the how it actually generates that output, that turns out to be the absolutely critical detail.
Okay, this brings us to our two main suspects in this investigation. In one corner, you've got the default, the Myers algorithm. This one's the old guard. It's been in Git forever, and it is laser-focused on one thing, finding the smallest possible change, the absolute minimum. Then in the other corner, you have the challenger, the histogram algorithm. It's a bit newer, and it thinks differently. It tries to find a change that actually makes more sense for code, because it gets the developers move entire blocks around. So you have this core conflict, minimal change versus a semantically correct change, and that's the whole ball game.
So the researchers, they had this hunch that this choice of algorithm really mattered. But first, they needed to figure out what people were actually doing out in the wild. Were developers and other researchers even aware they had a choice? This leads us to the first major clue in their investigation, a massive, and I mean massive, unexamined assumption.
So how'd they do it? They started with something called a systematic mapping. Just think of it like a super rigorous detective survey. They systematically combed through all the top academic papers in their field to basically create a map of what everyone was up to, looking for trends and, more importantly, looking for blind spots. And what they found, honestly, it's staggering. Get this. Out of 52 high-impact software engineering papers they looked at, 51 of them, that's 98%, just used the default Myers algorithm without even mentioning it, without a second thought. An entire field of research was being built on a default setting that basically no one had ever questioned. This was it. This was the giant blind spot they were looking for.
Okay, so we've found the blind spot. But the big question is, does it actually matter? I mean, so what? Well, the next phase of the investigation was to stop just surveying people and to start measuring. They needed to quantify just how different the results from these two algorithms really were. And here's the first piece of hard evidence. There's this metric called code churn. It's basically just how many lines are added or deleted in a change, and it's a really key metric for predicting software quality. The researchers found that for up to 8.2% of commits, this fundamental metric gave different answers based only on which algorithm you used. Think about that. Your predictions about software quality could literally change just because of a hidden setting. But wait, this is where it gets really critical. One of the most important things you can do in software research is find the exact change that introduced a bug, right? Well, the algorithms disagreed on which commit was to blame for up to 13.3% of bugs. Let that sink in. It's exactly like having two detectives analyze the very same crime scene, and then they point their fingers at two completely different suspects. That is a massive discrepancy.
So, okay, we've established they give different results, wildly different in some cases. But that leads us to the ultimate question. Is one of them actually better for analyzing code?
And that's exactly what the researchers set out to prove next. They switched gears from all this automated quantitative stuff to a pretty painstaking manual review. They took 377 different code changes and actually had human experts sit down and judge which algorithm's output was more logical, more readable, which one better reflected what the developer was actually trying to do.
And folks, here it is, the smoking gun. In that manual analysis, the human experts judged the histogram algorithm's output to be superior over 62% of the time. The default Myers, it was only judged to be better in about 17% of cases. I mean, it wasn't even close. For understanding what's really going on in a code change, histogram was judged to be nearly 4 times better. 4 times!
This table really just summarizes the whole journey perfectly. You can see how they did it. First, they identified this massive field-wide blind spot. Then they proved it had a real quantitative impact on key metrics like code churn and bug introduction. And finally, through that manual analysis, they proved the histogram algorithm wasn't just different, it was flat out superior. It's just such a rigorous and compelling case from start to finish.
Okay, so after all of that evidence, where do we land? What's the final verdict from this whole investigation? And, more importantly, what should you do about it?
Well, the paper's conclusion is about as clear and direct as you can get. Based on all their evidence, the authors issue a strong recommendation, their words, to use the histogram algorithm when you're analyzing source code. And look, this isn't just their opinion, right? This is a data-driven command, basically, from world-class researchers.
So, what's the practical takeaway for you? Well, for developers, start using git-diff/histogram during code reviews. It's going to give you a view that's much more likely to match what the author was actually thinking. For researchers, the message is even stronger. Any analysis of code history from now on really has to use histogram to be taken seriously. And for pretty much everyone, it might just be time to pop open your .gitconfig file and change that default for good.
And that brings us to the final, bigger thought here. This whole investigation is just a brilliant illustration of the danger of defaults we never examine. It leaves us with a really provocative question, one I want you to think about. What other defaults are hiding in the tools you use every single day, quietly shaping your work, your results, in ways you've never even thought to question?